We're continuing with our review. Remember, this is the AP 2003 AP exam. Also, remember, if you want to do this efficiently, look at the question, stop the video, try to do the question on your own, and then look to see what the solution is. So, here comes question number 16. You are told, if the tangent line to the graph of the function f at the point 17 passes through the point -2, -2, find f prime of 1. So what do we need to do? We need to find f prime of 1. This is a conceptual question. By no means is this a hard question. So they're asking this question to see whether you understand what f prime of 1 means. F prime of 1 means the slope of the tangent line when x equals 1. So basically, what's this question asking you to do? To find the slope of a line when the x-coordinate of the point is 1. Well, we have a point 1, 7, and so to find the slope of the line, you need 2 points, and a second point is given to us as well, -2, -2. So really, all you need to do to find f prime of 1, you need to find the slope. So -2 minus 7 over -2 minus 1. -9 over -3 or 3. Better yet, you can just look and see the change in y is -9, the change in x is -3. And so slope -9 over -3 or 3. Is there more to this question? No, that's all this question asks you to do. So, if you know what f prime of 1 means, the question is actually an Algebra 1 question. If you don't know what it means, then you can't do the question. Question number 17. Question number 17 has to do with concavity. Better yet, it has to do with when is a function concave down. Again, a short review. When is a function concave down? A function is concave down when the second derivative is less than 0. So if f double prime of x is less than 0, then f is concave down. So what's this question asking you to do? This question is asking you to take the derivative not once, but twice, and it's asking you to use the product rule. So before you do this problem, what you should know is the product rule. We'll review it one more time. If h of x is equal to f of x, not f of g, but f of x times g of x, then h prime of x is equal to the derivative of the first times the second plus the first times the derivative of the second. Now that you know the concepts, we're ready to do the problem. Sorry if I erased it too quickly. Let me write it down one more time. Plus f of x times g prime of x. The product occurs right here. We have the quantity 2x times e to the x. So this is your f, and that is your g. So let's start. F prime of x is equal to the derivative of 2x, which is 2 times e to the x, plus the first, which is 2x, times the derivative of e to the x, which is just e to the x. We don't need the first derivative, we need the second derivative. Let's take the derivative again. F double prime of x is equal to 2e to the x plus, again we need to use the product rule, so the derivative of 2x is 2, so 2e to the x plus 2x times the derivative of e to the x, so 2x e to the x. So f double prime of x is equal to 4e to the x plus 2x e to the x. We can factor 2e to the x, so 2e to the x times 2 plus x. Good. So you know what f double prime of x is. Your next step is to set it equal to 0. So set f double prime of x equal to 0. So 2e to the x times 2 plus x equals 0. 2e to the x is always positive. You can even divide by 2e to the x if you want to. So 2e to the x equals 0. We're going to use the zero product property. Plus, or 2 plus x is equal to 0. Like I said, 2e to the x is always positive, can be equal to 0. Well, here we get that x is equal to negative 2. I'm going to erase the product rule. I'm going to draw a number line. And on that number line, we only have one number, the number negative 2. If I use numbers such as negative 3, then 2e to the x is positive, while 2 plus negative 3 is negative. And if I use numbers greater than negative 2, like 0, we get a positive times a positive, which is a positive. So this is the sign graph for the second derivative. The second derivative is negative to the left of negative 2. So we write f is concave down on the interval from negative infinity to negative 2. Although we're not asked, it's a good review. At negative 2 we have an inflection point because the graph changes from concave down to concave up. And that's all there was to problem number 17. I'll erase 17 quickly. While I erase the board, you can take a look at question number 18. There's a lot of information. Read it carefully. I'll underline the clues that are very important to do this problem. So, the derivative g prime of a function g is continuous. It's very important to know that the derivative is continuous and that it has exactly 2 zeros. We're given a table with selected values of g prime, and based on those values, we have to figure out where g, the function g, is decreasing. Let's quickly review that. G is decreasing when g prime of x is less than 0. So what we're going to do, based on this table, we're going to make a sign graph. On the line, on the number line, what we're going to do is we're going to start with the zeros. So we notice that g prime of negative 2 is equal to 0, and g prime of 2 is also equal to 0. So g prime of negative 2 equals 0. G prime of 2 is also equal to 0. Those are the two numbers that will go on the number line. Then we use some test points. Let's start to the left of negative 2. We notice that g of negative 3 is 3. So g of negative 3 is positive. And so let me just draw the graph of g prime. Now this is, I have no idea what the graph looks like, but I do know that the function is continuous. So I don't know what it looks like. And I don't really care what it looks this is a possible graph of G prime. What's the only thing that is important to me? It's important to me that G prime is continuous and there are no gaps, no jumps, nothing in the graph. So once the graph of G prime is below the x-axis, it will stay below the x-axis, and once the graph of G prime is above the x-axis, then it will stay there, because the graph of G prime only crosses the x-axis at 2 points. So let's continue. The next test point that I'm going to use is 0. I notice that G prime of 0 is -2. That means that between -2 and +2, the graph of G prime is negative, or the values of G prime are negative. And finally, if we choose a test point to the right of 2, like 3, we notice that G prime of 3 is equal to 3. So since G prime of 3 is equal to 3, it means that the first derivative is positive to the right of 2. So we're ready to answer the question. G is decreasing when G prime of x is less than 0. G prime of x is less than 0 between -2 and 2. So G is decreasing on -2 is less than x, which is less than 2. And that's all there is to this question.